Okay, Apsara, today we are going to solve a February March question of 2025, and the paper 1, the variant is 1 2. Paper 1 mean it's a non-calculator paper. Okay, right. Look at here, sir. Paper 1 non-calculator is it's written in the in the front page. Okay. Yes, sir. Okay, so now let's go to the question number 1 directly. So here in this question number 1, this is a modulus question. It says that on the axis sketch the graphs y is equals to y is to 4 times x minus 1 and y is equals to modulus of thrice x plus 2. This is also modulus stating the intercept with the x's. Okay, so we have to state the x intercept and y intercept as well. You understand? For x intercept for x intercept, what can I write? This portion would be for x intercept y is 0, right? For x intercept y is equals to 0, that will give us x minus 1 is equals to 0, hence x is equals to 1. So at x is to 1, the graph will be reflected or bounced on the x-axis. You understood? Yes, sir. And for this portion, I can write thrice x plus 2 is equals to 0. So x is equals to minus 2 over 3. That means minus 2/3. Okay. And for y-intercept, where x is equals to 0, I get like y is equals to 4 times 0 minus 1, which is y is equals to 4, and another one is y is equals to 0 plus 2, hence y is equals to 2. Okay. Yes, sir. So since this is a sketch, let me bring my pencil. Please wait. So now I have brought my pencil. So I am taking this 1 centimeter as like 1. What is the x-intercept? I got 1. This minus 3 over 2. So I'm taking this one. Okay. Here. This is 1 as positive 1. And this is 1 as negative 1, because why did I take this? Because then this would be my minus 2 over 3. Y-intercept I got 4. So I'm taking in this scenario. Okay, I can take again 1 2 3 4. So I can take this as my 4 and this is my 2. Okay, so this is 1, this is minus 1, and here is minus 2 over 3. So since this is 1, we have to find another 2 to draw it completely accurately. Here again this is 2. So this curve, this one, it will pass through 4. Okay, like this, one half, and the another half will go like this, like from 2, just like here, this point. So it will be like this, it will go in this direction. Okay, I have sketched this part. Okay. Yes. Now for this, here is the x-intercept, it will pass through 2. So I'm giving 2 here, giving 2 here, and again it's in another this is 2, sorry, centimeters, in within 2 centimeter. Here it will cross 2 again, so something like this. This point, so it will go like this. If you observe, this line has gradient 4. This is y is equals to 4x minus 4. This line is gradient 4. This is y is equals to thrice x plus 2. That means these two lines will converge in future, right?
Yes.
Okay. And I should have like taken this like axis a little closer so that like I could have shown the point of intersection, but that doesn't matter. They didn't say the state starting the intercepts with the axis. They didn't say the intercept of the curve. Okay, therefore our drawing is completely okay. Now, one thing to observe: these two lines will never meet. If you observe, these two are diverging. These two lines will never meet in future. They are diverging. So what this is one intersecting point is visible, another intersecting point is not visible, which will happen in future if you continue to extend these two lines. Did you understand that part?
Yes, sir.
Okay, so therefore like this equation is, and what is the equation of this line? This is y is equals to 4 minus 4x. So y is to 4 minus 4x and y is equals to thrice x plus 2 will intersect at this point. Why I am saying so? Because in part B, it asked us to solve the inequality where 4 times modulus of x minus 1 will be less or equals to modulus of thrice x plus 2. So in order to get this inequality, we first need to find the point of intersection between these two modulus curves. Okay. So at what did I tell? This line is thrice x plus 2 and this line is 4x minus 4, and here they will intersect. So I can write thrice x plus 2 is equals to 4 minus 4x. So what will I have? 7x is equals to 2. Hence x is equals to 2 over 7. Okay.
Yes, sir.
And again, this line and this line will intersect in near future. So I can write thrice x plus 2 is equals to 4x minus 4. So I will have what can I say, 6 is equals to 4x. So x is equals to 6.
You need to scroll up a little.
Oh, sorry. Yeah, it's x equals to 6. Did you get this part?
I did.
Okay. I forgot to write with pen, so I keep continued writing with pencil. Okay, from next math I will write with pen. Okay. So now we have found two intersecting points. So now we have to decide about the inequalities. It says this graph is less than this 4x. This 4x graph is less than. That means it when it's less than, here this point is minus 2 over sorry, this point is, this x is 2 over 7. As soon as the x becomes larger than 2 over 7, this curve becomes smaller than this curve. How long will it be smaller? Up to x equals to 6. Therefore, our inequality will be x must be less or equals to 6, since it has equal to, with the inequality, less or equal to 6 but greater or equals to 2 over 7. Okay. Okay.
Yes, sir.
Okay. So question 1 is done. It's time to go to question number 2. Okay. Okay. Now for the second question of this paper. This is a trigonometric graph has been given to us, and it's a cosine curve. Okay.
Yes.
Cosine curve, and the range is, the graph is drawn from minus 180 degree to positive 180 degree, and they have used the generic format of the equation, of the graph, which is y is equals to a cos bx plus c, and it's given that a, b, c are integers. We have to find the value of a, b, and c. So do you know this part? Like if for a generic expression for any cosine x or sine x, a sine bx plus c, or y is equals to a cosine bx plus c. This c is the reference line, that, or yes, you can say it's the midline between the highest value and the lowest value of the graph.
Yes, sir.
A is the amplitude. That means it's the difference, the distance between the highest point and the midpoint, or the lowest point and the midpoint. B is the number of complete cycles within 360 degree or 2 pi. So this is given in degree, so I can say B is the number of complete cycles within 360 degree. So now at first I will try to find the value of C. What is the maximum value here? Look, what is the maximum value? 3, right? Hello.
Yes, sir.
And what is the minimum value of this graph?
Minus
7. So C should be minus 7 plus 3 divided by 2. So it is what? It is what? Minus 4 divided by 2. So C should be minus 2. Okay. Minus 2 is our minimum. The reference line. So this line is the reference line, which is our minus 2 line. Okay. So I'm giving this line. This is y is equals to minus 2. So what is the difference between this line, from this line to this line? This should be the value of A. So therefore A should be uh, 3 3 minus minus 2, 3 minus minus 2. So A should be 3 plus 2 means 5. Okay. Then the cosine curve 0, from 0 it starts from here, right? Look, from 0 up to this it completes one cycle, and then up to from to 180 it completes 1.5 cycle, right? Hello.
Yes, sir.
Or you can say it's like so within, I told you, within 360 how many complete cycles should we have? That is the value of B. So here, if you here you can, like, you can think from this point up to this point one cycle, from this point up to this point another cycle, from this point up to this point another cycle. So we have 3 cycles. Or you can say from 0 to 180 it actually have 1 point. From for 180 degree it has 1.5 cycles. So for 360 it will have 1.5 times 2, which is 3 cycles. Hence the value of B must be 3. Okay.
Yes, sir.
So our question number 2 is done. Okay. Now we'll move to question number 3. Now let's read the question number 3 here. What it says, the point A has coordinate minus 3, 6. The point B has coordinates minus 7, 8. Given that the line AB is the diameter of a circle, find the equation of the circle. Okay, fine. If A and B is AB is the diameter of the circle, the midpoint of AB must be the center, right?
Yes, sir.
So midpoint of AB, that should be minus 3 plus 7 divided by 2, comma 6 plus 8 divided by 2. What will you have? 4 divided by 2 means 2. 14 divided by 2 means, sorry, it's minus 8. Why aren't you saying anything? Oh no, I wrote.
I'm so sorry.
You are zoned out.
I was doing my one.
No, you are not supposed to doing your one when I am writing.
Right, I'm so sorry.
Midpoint of AB is minus 3 plus 7 divided by 2, comma 6 plus minus 8 divided by 2. So now you will have 4 divided by 2, that is 2, comma, and this is this is what? 6. This is what? Can you tell me?
Minus 2 over 2.
Minus 2 over 2. That means minus 1. Okay. Okay. So this is the center of the circle. Okay. Now I need to find the radius. Radius, from, you can choose any point up to this point. For example, let's give this point a name C. So I need to find the length AC, and that should be the radius. So minus 3 minus 2 whole squared plus 6 minus minus 1, that means plus full squared. Okay. So AC square. Okay, fine. At first, how do we write the equation of a circle? X minus a whole squared plus y minus b whole squared equals to r squared, where the center is actually a comma b and radius is r. So since this is r, I don't need to do the square root. I can directly at the equation, look what we write r squared. So I can write r squared equals to, I'm eliminating this square root. This is what, minus 5 whole square, that means 25, right? 25
Yes.
plus this is 7 squared means 49. So r square is actually 74. So equation of the circle that is x minus 2 whole squared plus y plus 1 whole squared equals to 74.
Okay.
Okay.
Yeah.
So question 3 is done. Okay.
Yes.
So now this is our question number 4. So this is a math from factor theorem and remainder theorem. Let's see here, it only says factor, there is no remainder here. Okay, fine. So it's only from factor theorem. The polynomial p is given by px is equals to a squared times x cubed plus 2a times x squared plus a times x plus 2, where a is a positive integer. It's given that 2x plus 1 is a factor of px. Find the value of a. Okay. So 2x plus 1, at first I can write 2x plus 1 is equals to 0. Hence, x is equals to minus half. According to factor theorem, p of minus half must be 0. Because factor theorem tells us this part. Okay.
Yes, sir.
Since 2x plus 1 is a factor, that implies p of minus half should be equals to 0. Okay, fine. So now substituting the value minus half instead of x, I can write a squared times minus half whole cubed plus 2a times minus half whole squared plus a times minus half plus 2 is equal to 0. So now I can get a squared, and this is minus 1 over 8. This is plus 2a times only 1 over 4 because it's an even power, and here it will be minus a times half plus 2 is equal to 0. Okay. So this and this gets out, crosses out, and we got a times half. Here it is a times half is minus a times half, so entire things can get crossed out. Okay. So now we have minus a squared over 8 is plus 2 is equal to 0. Therefore, a squared over 8 is equals to 2. Hence, a squared is equals to 16. But we are not interested in a squared. So a should be plus minus 4. But it says that a is a positive integer. So therefore, a is equal to 4 is the only answer. A is equal to minus 4. This is not applicable for this question. Okay. This is the only answer. Got it? Did you get it?
Yes, sir. I got it.
Okay. So and now it says hence factorize px. So I'm going to use the third line method. If you're not comfortable with third line method, just be patient. Okay. So px using the value of a, I can write a squared means 16x cubed plus 2a, that means 2 times 4 is plus 8a squared plus 4 times a 4 times x, that means 4x plus 2. I'm giving the gap in the second line. I'm in the third line, I'm writing at first 2x plus 1. So I need 16x cubed at first. In order to get 16x cubed, I can write 8x square, right? So if I write x, oh, why did I write a? It should be x squared, and you are not saying anything. Okay. Now this is plus 8x squared. Okay, we got first two terms. Now I need only the second term, so it will be like this. So like here I'm like again 2x plus 1. So here we need 4x. What, in order to get 4x, what do we need to multiply with? We need to multiply this factor with 2. So I will
Yes.
get 4x and then plus 2. Now we have this 2x plus 1 and 2x plus 1 as a common factor. Taking it out, I can write px is equals to 2x plus 1 times 8x squared plus 2. But it is still not factorized completely. Why? Because 8 is an even number, 2 is another even number. So taking it out, I can write 2 times 2x plus 1 times 4x squared plus 1, that is equals to 0. Okay. Now it is, it's not equals to 0. It has been factorized completely.
Okay.
Okay. Now it says hence show that the equation px is equals to 0 has only one real root. Okay. So px can be written as 2x plus 1 times 2 times 2x plus 1 times 4x squared plus 1. So this factor will give us x is equals to minus half, which we started with this information. We started the solution of this question, right?
Yes, sir.
And here another option is like px equals to 0. Sorry. So another option would be 4x squared plus 1, that is equals to 0. But 4x squared equals to minus 1. So x squared is equals to minus 1 over 4. A square number can never be a negative. So it will not give us any solution.
Got it.
I'm telling it again. A square number can never be a negative. Therefore, this
Okay.
part has no solution. So so x is equals to half is the only root for px is equals to 0. Okay.
Yes, sir.
So can I move to the next question? Since our question
You,
4 is done. Can I move to
yes,
the next question?
you can.
Okay. Okay. So now we have reached to the question number 5. So here a quadratic expression has been given to us and they have asked us to write this quadratic expression in this form, which is the completing square form, where a, b, c are constants. Okay. So I can write from these two, from these first two terms, I can take 2 out. So I can write 2 times x squared minus x plus 3 in the first line. Okay. Next, I can write 2 times x squared minus 2 times x times, we need a half. So half is our b, so therefore it will be followed by positive b squared, which is positive half square. Since half square was not there, so we are eliminating it immediately by giving a negative half whole square. And
Okay.
the entire thing is multiplied by 2, and the plus 3 was outside, so let's keep this plus 3 outside. Now we will have 2 times this entire thing will give us x minus half whole squared minus 1 over 4 plus 3. Okay. Now if
Yes,
you
sir.
multiply 2 with these two terms, we get 2 times x minus half whole squared minus 2 half plus 3. So what is 3 minus half? 3 minus half is nothing but 5 over 2. Okay. So
Okay.
finally I can write 2 times x minus half whole squared plus 5 over 2. Done this portion?
Yes. Yeah.
Okay. Now it said that it's given that fx, a function, is defined as 2x squared minus 2x plus 3 for x lesser or equals to b. Okay. I mean, like, this expression is now become a function and the domain is defined as x lesser or equals to b. Write down the greatest value of b for which the f has an inverse. Okay, fine. For inverse, the function has to be, or function must be, a one-to-one function. Any quadratic by nature is a many-to-one function. For example, if I draw the rough sketch of this quadratic, here this line is x is equals to half. Now this is basically a many-to-one function. Because if you draw any vertical line, it's crossing in two different portion of the curve.
Got it.
Therefore, it is right currently a many to one function.
Okay.
How can we make it one to one function? By eliminating either this part or this
Or this
part.
one. Right.
Which part we will eliminate? It will be defined by the given domain. Domain said x must be less or equals to. So the value of x will decrease. So therefore, this portion will not remain. The only remaining part will be like this up to this. Okay, where this is x equals to half. So since the value decreases in this direction, the value of x decreases in this direction, the value of line of symmetry where the x is half is the greatest value of this in this range. Do you understand that part?
Yes, sir.
I'm telling it again. In this direction, the value of x decreases. Therefore, the value of x, which is at the turning point, is actually the greatest value within this range. Okay.
Okay.
Now, so therefore, write down the greatest value of p for which the function has an inverse. So p is equals to half. The explanation I have explained here. Now, it says that using the value of p, write down the range of f. Okay, fine. Let's rewrite the function in completing square form. What we have found, fx is equal to 2 times x minus half whole squared plus 5 over 2. It is a minimum curve and this is the minimum value. Therefore, the fx must be greater or equals to 5 over 2. Even if the function was like x greater or equals to p, the minimum value would have remained the same. But that if the domain was written in this pattern, the value of p would be the least, not the greatest. Okay.
Right.
Okay. Now, using this value of p, they have asked us to find the inverse of this function. Okay, fine. Let y is equals to fx. So I can write 2 times x minus half whole squared plus 5 over 2 is equals to y. So now I can write 2 times x minus half whole squared is equals to y minus 5 over 2. Can I write up to this?
Yes, we can.
Then I can write x minus half whole square is to half times y minus 5 over 2 up to like this. Now if we do the square at both sides, we will get x minus half, that is equals to square root of half times y minus 5 over 2. But when do we square root, we usually place a positive and a negative sign. But here I cannot use the both sign. I have to use one sign. Which sign will I use? Again, it will be dictated by the given domain. X was given, x was less or equals to half. That's how the domain was given to us, right?
Yes, sir.
So therefore, we will place a negative here. If the direction was like this, if the domain was given like this, we had to place plus here. Okay.
Yep.
Now we will have x is equals to half minus square root of half times y minus 5 over 2. But our task is not completed yet. We have just made x as subject, but we haven't declared what is our f inverse x. So right now I will declare. So our f inverse x is actually half minus square root of half times x minus 5 over 2. Okay, or any equivalent of this expression. Clear?
Yes, sir.
Okay, so question 5 is also done, right?
Yeah.
Okay. So now it's time to solve the question number 6. It's a trigonometry math, and basically it's a very simple math actually. It is given that tan theta is equal to square root 5 over 5 and the theta belongs from 180 to 360 degrees. That means it could be in the third quadrant or in the fourth quadrant. Let me draw like four quadrants. First, it's like Sorry, why the, so here this is from 0 to 90, right? This is from 90 to 180. This is 180 to 270, and here it's like 270 to 360 degree. It says from 180 to 360. So the triangle could be here or triangle could be here. But in this third quadrant, tan theta is positive, and we have the positive ratio. Therefore, the angle must be in the third quadrant. Okay.
Okay.
Okay. So now I can draw a right angle triangle here, just like that, where this is a theta and tan theta is opposite over adjacent. So opposite, it is square root 5. The length is square root 5, but the vector is minus square root 5, and adjacent is 5. So length is basically the length is 5, but the vector is minus 5. Okay. And now what is missing? The hypotenuse. Let's call this length L. So how do we get L? We can, by Pythagoras theorem, we can write L square equals to minus square root 5 whole squared plus minus 5 whole squared. Hence L squared equals to, this is 5 plus 25, this is 30. Okay. Therefore, yes, L is equals to square root of 30. So this is square root of 30. Now what is cos theta? They have asked us to find the value of cos theta. What is cos theta? Adjacent over hypotenuse. So I can write cos theta is equals to, adjacent is minus 5 and hypotenuse is square root 30. I can keep it like this because they haven't asked us to what can you say, rationalize the denominator, but as a good practice we will do. Okay. So I can, what can I do? I can here multiply a square root 30 here, another square root 30 here. So what will I get? This is minus 5 square root 30 divided by 30. So 30 divided by 5 will give us 6. So now I will have minus square root 30 divided by 6. So this is our cos theta. Okay. Okay. Now they have asked us to find the value of sine theta. So sine theta is nothing but what? What is sine theta? Can you tell me? Opposite over hypotenuse. So sine theta is, what was it in our opposite? Minus square root 5 divided by square root 30. So that can be written as, keeping the minus outside, square root 5 divided by 30. So it could be written like minus 1 over square root 6, right? So minus 1 over square root 6. So if you want to rationalize, I can multiply a square root 6 here, I can multiply another square root 6 here, and I will get finally minus square root 6 over 6. Okay. Okay. Yes, sir. Do you have any confusion or any question regarding this? Okay. Now they have asked us to find the value of sec theta and cot theta. So reciprocal of sec theta is cos theta. Reciprocal of cot theta is tan theta. That means sec theta is 1 over cos theta and cot theta is 1 over tan theta. We have everything. We have cos theta. We have tan theta given in the original question. So now just let's try to find the sec theta. So sec theta is equals to 1 over cos theta. But what did we find in cos theta? Minus square root 30 over 6. So it will be reverse, right? Yes. So it will be like minus 6 divided by square root 30. Let's keep it like this. I am not interested in making it like denominator rationalization is not important at this moment, because look, they have a square root in the denominator. Yes. Understand? So for that part, I can do one thing. I can like this minus 6 divided by 30 is 30 can be written as 5 times 6, since we have a square root 5 here. That's why I'm separating or I'm splitting square root 30 in this manner. Square root 6 times square root 5. Okay. Okay. Now, what is cot theta? Cot theta is 1 over tan theta. In the original question, tan theta was given as square root 5 over 5. So therefore, it will be just 5 over square root 5. Okay. So
Yes, sir.
here we have a square root 5 in the denominator. Here is another cot theta. In cot theta, we have another square root 5 in the denominator. So now sec theta plus cot theta will give us minus 6 divided by square root 6 times square root 5, and it is plus 5 divided by square root 5. So can we take 1 over square root 5 common?
Yes, sir, we can.
Okay. Now we now we'll have inside the bracket minus 6 divided by square root 6, and here plus 5. Okay.
Yes.
But if we can rationalize here, like we can multiply a square root 6 here and another square root 6 here, so eventually we'll get 1 over square root 5 times minus 6 square root 6 divided by 6 plus 5. So 6 and 6 gets crossed out. Now what will we have? What can we have? Wait a minute. So now we have like this 1 over square root 5 times minus square root 6 plus 5. Look how they have asked us to present the answer: a plus b squared c divided by square root 5. So since 1 over square root 5 is already multiplied, so I can just write like this: square root 5 in the denominator, and here we can write 5 minus square root 6. Okay.
Where is B?
1. It could be 1. If
Right.
nothing is here, it could be minus 1. I mean, like, since it's plus, is his here the sign is plus, so here sign is minus. So
Yes, sir.
you can think the value of b is minus 1. They didn't ask to evaluate the value of abc. If they had asked they have asked to evaluate the value of abc as integers, then we have to write a is this, b is this, and c is this. Now they have asked us to just to represent the answer in this format, and we have presented the answer in this format. Okay.
Yes, sir.
Okay, so question 6 is done. So now we'll start solving question number 7, and looking at it, you can say this will be definitely an integration question, right? And they have to ask, they will ask, I don't know, here is only part A is visible. In part B, maybe they will ask to find the area of the shaded region.
Right.
So let's read the question first. The diagram shows the part of the curve y equals to 5 over x plus 1 plus 2. I mean, like this is the curve. Yes. And part of the line y is equal to 2x plus 1 intersecting at point A. This is a straight line, and the equation of this straight line is 2x plus 1. They intersect at point A. They have asked us to find the coordinates of A. So simply we can do the simultaneous equation. This is y and this is also y, right? So can we write from the very first line, I mean, like equating these two lines, I mean, like this 2x plus 1 is equals to 5 divided by x plus 1 plus 2. Can we write like this?
We can, sir.
Okay, now in the next line I can write 2x, if we subtract 2 from the both side, 2x minus 1 is equals to 5 over x plus 1. So now multiplying x plus 1 with the both side, I can get 2x minus 1 times x plus 1 is equals to 5. Okay, so now expand this. Now we will get this 2x squared minus x, and here is plus twice x minus 1, and then minus 5 is equal to 0. So now we will have 2x squared plus x minus 6 is equal to 0. So if we do the middle term factorization, what will I have? I will have 2x squared plus 4x minus thrice x minus 6 is equal to 0. From these first two terms, 2x is the common factor, so let's take it out. If you take the 2x factor out, we'll have x plus 2, and here minus 3 is the common factor, so then we also have x plus 2 is the other factor. Now x plus 2 being the common factor, let's take it out. X plus 2 times 2x minus 3 is equal to 0. Hence, the x coordinate could be x equals to minus 2 or x equals to 3 over 2. But if you look at A, it is the right side of the x-axis where x is positive, right?
Yeah.
So x minus 2 cannot be a valid answer for this question. So x is to 3 over 2. But what was y? Y is like 2x plus 1. So y is equals to 2 times 3 over 2 plus 1. Therefore, y is equals to 2 base cross out, 3 plus 1 is 4. So a is 3 over 2 comma 4. Here is the whole map. Okay. Okay.
Yes.
Now, if we go to the next part of this question, which is B, what it said, find the exact area of the shaded region. Oh, they have. I have missed the one word, exact area.
Exact.
Why it is exact? Because it's a non-calculated paper, so there's no way you can find the area in decimal. It has to be exact. Okay. So now let's plan. In order to find the area, let's plan. The shaded area should be area under the curve minus the trapezium here, right?
Yes, sir.
Minus the trapezium. If we draw a line here from A to the x-axis, so here it's like, let's point this B and C. So let's say this is, let's call this is B, this is C. So OBAC is the trapezium, right? Here the x coordinate of B is 3 over 2. X coordinate of C is, being on the y-axis, is 0. So I can write at C, look, I have to write here at C our x is equals to 0. That implies y is equals to 1, because y is equals to what was given as y is equals to 2x plus 1. It was given as the straight line of the equation, right? As the equation of the straight line. Okay.
Yes.
Okay. Now, sorry. If we write the planning area of the shaded region, that has to be area under the curve, minus, which let's call this A1, minus area of the trapezium. Let's call this A2. Okay.
Yes.
So A2 is simple. So let's try to find the A2 first. A2 is, if you look at the picture, here we found this is 1, right? So here the length is 1. Here the A coordinate is 3 over 2 times 4. Therefore, this length is 4. And from this up to this, OB is 3 over 2. So the trapezium area is half times 1 plus 4 plus 3 over 2, which is like 5 times 2, 5 times 3, 15, 15 divided by 4. Okay?
Yes, sir.
We found the A2. Now the A1 remains. A1, that should be from 0 to 3 over 2, 5 over x plus 1 plus 2 dx. Let's split them separately. So we can write 0 to 3 over 2, 5 divided by 5 times 1 over. Why did I write the 5 outside of this integration thing? Because 5 is just a constant coefficient. It will remain as the multiplying factor. It will not take part in the integration. So x
Yes, sir.
plus 1 dx, and then plus again from 0 to 3 over 2 only, sorry, let's keep the 2 here and here dx. Okay, so 1 over integration of 1 over x dx is actually ln x. So here is again we will have 1 over 1 or x plus 1, so we'll get 5 ln x plus 1, and the limit is from 0 to 3 over 2 plus 2 times dx. The integration of dx is x from 0 to 3 over 2. Okay, the integration is done, only the now the limit substitution is remaining. So 5 times the ln, this is 3 over 2 plus 1 minus ln 0 plus 1, 5 multiplied with both of the terms, plus 2 times x 3 over 2 minus 0 is 0, so I'm not writing that part. Okay, so 2 and 2 gets crossed out here. So this is ln 1. What is the value of ln 1? Any logarithm 1, any log base could be anything, 1 is always 0. Therefore our a2 should be 5 ln, this is 5 over 2, right? 5 over 2,
Yes, sir.
and here is plus 3, so this is a2. And now our area of the shaded region, area of the shaded region, that is equals to a1 minus a2. So 5 ln 5 over 2 plus 3 minus 15 over 4, not 3, 15 over 4. Okay, here
Yes, sir.
it was 15 over 4. So that will be equals to 5 ln 5 over 2 plus, what can I write this? This is 12 over 4 minus 15 over 4. Now we have the common denominator as 4, so I can write 5 ln 5 over 2 minus 3 over 4, and this is the final. Oh, it's not visible. Why aren't you saying it's not visible? The area of the shaded region is 5 ln 5 over 2 minus 3 over 4, and this is the exact. Okay,
Yes, sir.
okay,
Yeah.
so we are done with our question number 7. Okay,
7.
okay, now this is question number 8, and it's definitely from arithmetic progression and geometric progression. So let's read the question first. The first term of a geometric progression is 10. The geometric progression has a positive common ratio r. Okay, the first term of an arithmetic progression is also 10. So both the progression has the first term as the common term, sorry, the common value, and
Yeah,
then the
10.
value is 10.
10, yeah.
The arithmetic progression has a negative common difference. Okay, that's a good hints. I don't know whether it will have any effect or not. After doing the math, we will be able to understand that. The second term of a geometric progression is the same as the fourth term. So now a comparison between a geometric progression and arithmetic progression is going on. So therefore, they will give us another comparison. The third term of the geometric progression is the same as the sixth term of the arithmetic progression. Okay, fine.
Okay.
So now you can think, what is nth term of a arithmetic progression? Tn is equals to a plus n minus 1 times d, where a is the first term and d is the common difference. Okay,
Yes, sir.
so since they have given us what can you say, comparison, so I'm writing in a table. It's not mandatory, but I just follow this practice like any other non-mandatory task. Okay,
Yes, sir.
yeah, like we can tell, like this is first, and here let's say this one, this is for GP. Okay,
Yes.
and this is for AP. So it says that both term a, I mean like the u1 is equal to 10, and here is also that I can write T1 is also 10. Okay, the GP's second term, which is U2 we don't know about it, but it says that it is the fourth term of the arithmetic progression, right? So the
Yes.
T4, so T4, using this formula we can write 10 plus 3D. Got it?
Can you explain again? I'm sorry.
Like, this is one, like any nth term is A, that's its first term, plus n minus 1 times D. Here the value of the n is 4. Therefore A, that means 10, plus 4 minus 1, that is 3D.
Okay, right. Yeah, sorry.
Okay.
Got it, sir.
Okay. Thank you for asking. Now it is like this term 3. This is what is term 3 is the sixth term. Okay. So T6. T6 means 10 plus 5D. Can I write?
You can.
Okay. Now what is R? The common ratio R can be defined as U2 divided by U1. What is U2 here? U2, this one, right? 10 plus 3D divided by 10. But R can also be defined as U3 divided by U2. What is our U3? 10 plus 5D. 10 plus 5D divided by 10 plus 3D. So this is R. This is also R. So I can equate them.
Okay.
Therefore, I can write 10 plus 3D divided by 10. That is equals to 10 plus 5D divided by 10 plus 3D. So if we rearrange the equation, we can write 3D plus 10 whole squared is equals to 10 times 10 plus 5D. Can we?
We can, sir.
Okay. Now in the next line, this is a plus b whole square identity. So I can write 9d squared plus 2 times 3, 6 times 10, 60d plus 10 squared means 100 is equals to, this is 10 times 10, this is 100 plus 50d. 100 gets crossed out and we get 9d squared. 60 plus 60d minus 50d is equal to 0. So now in the next line I get 9d squared plus 10d is equal to 0, right?
Yes.
We can take d is a common factor here. So if we take d out, we can get 9d plus 10 is equal to 0. Therefore we have two solutions, right? This is
Yes, sir.
d is equal to 0. In arithmetic progression, d can never be a 0. If d is
Okay.
0, that's not a progression. So this is not applicable, absolutely not applicable. Another
Okay.
solution is like 9d is equal to minus 10. Hence d is equal to minus 10 over 9. And they also have given the hint that the common difference is negative. We found the negative. So we can think that this is the correct common difference. Okay.
Yes, sir.
Now R has been written in terms of D. Since we have found the value of D, we can use the value of D here. So R is 10 plus 3 times minus 10 over 9 divided by 10. 3 and 3 gets crossed out, right?
Yes, sir.
Now we can, since it's a non-calculator paper, I am utilizing a technique. I can take 10 common, then we get 1 minus 1 over 3 divided by 10. 10 gets cross out, and the 1 minus 1 over 3 is 2 over 3. Hence the value of R is 2 over 3. Okay.
Yes.
So we found the value of R. That is the common ratio of the geometric progression. It says determine whether the geometric progression has sum to infinity. For any geometric progression to have a sum to infinity, the modulus of R has to be less than 1. So modulus of 2 over 3 is already less than 1. Hence, the geometric progression has has a sum to infinity. Okay.
Yes, sir.
Any question?
No.
Okay. So can we go move to the next question?
Yes, you can.
Okay. Okay. Now we'll be solving the question number 9, and it's clearly seen that this is a question belongs to the logarithm. Okay. So now, like, do you know this rule of logarithm? Log a base b can be written as 1 over log b base a, where the base and argument swap the place and it becomes the reciprocal of its own term.
Yes, I know.
Okay, fine. So here it is log 2 base x plus 1, but here it's log x plus 1 base and 2 is the argument. So in the next line we can write using this relationship log 2
Yeah.
base x plus 1 minus 4 times 1 over log 2 base x plus 1, that is equals to 3. Okay.
Yeah.
So now I'm if I here we have log 2 base x plus 1, here we have log 2 base x plus 1. What if we assign a new variable instead for this entire expression? Let a is equals
Yeah.
to log 2 base x plus 1. That will give us a minus 4 over a is equals to 3. So now we can, if you multiply the entire equation by a, you will get a squared minus 4 is equals to 3a. So now I can write here is a squared minus 3a minus 4 is equals to 0, right? Now doing the middle factorization,
Okay.
I can write a squared minus 4a plus a minus 4 is equals to 0. So here for the first two terms, a is the common factor, so taking it out I can get a times a minus 4. It doesn't have any common factor, but when we have no one is the common factor, one is always is the common factor. Okay, so a minus, so 1 times a minus 4 is equal to 0. Now from this entire expression a minus 4 is the common factor. If we take it out again, we will have a minus 4 times a plus 1 is equal to 0. That will give us one solution as a is equal to 4 and a is equal to minus 1. Okay, but what was a? It was not a problem to solve a, right? It
Right.
was a problem to solve x. So
Right.
what was a? A was log 2 base x plus 1, and that is equals to 4. So do you know another relationship of log, like log a base x is equals to y, that can be written as x is equals to a to the power y? Do you know
Yeah.
this? Okay, fine. So here
Yeah,
the
but
base is 2, so I can write x plus 1 is equals to 2 to the power 4. What is 2 to the power 4? Is 16. So our x is 16 minus 1, hence x is equals to 15. So we have found one solution as x equals to 15. Okay, so here if we substitute x equals to 15, both log remains valid, so this must be a valid answer. And for this part I can again write log 2 base x plus 1 is equals to minus 1, hence x plus 1 is equals to 2 to the power minus 1. What is 2 to the power minus 1? It's nothing but half. So I can write x is equals to half minus 1. So therefore x is equals to minus half. Okay. So hence
yes.
this, like, look at x plus 1. X plus 1 is positive half, right?
Yes.
So if we can easily give positive half here, we can easily give positive half here. So therefore x is equals to minus half is another valid answer, and hence we have completed our question number 9. Okay.
Yes, sir.
Okay. So can we go to the next question?
You can.
Okay. Okay. Now we are in question number 10. So this question is basically, you can say, let's differentiation as well as coordinate geometry. Okay.
Yes, sir.
So let's read the question. The point P lies on the curve y is equals to 5x plus 2 whole to the power 2 over 3. The x coordinate of P is 5. The normal to the curve at P intersects the line x plus y is equal to 11 at point Q. Okay. So far we have 2-point reference, that is P, and another point is Q. The point R is the reflection of Q in the tangent to the curve at P. Find the coordinates of R. So in order to find the coordinate of R, since R is dependent on the point Q and P, at first we have to find the coordinate of P and Q.
Right.
At very first attempt, we can very easily find the coordinate of P because x coordinate is already given. If we substitute this x coordinate in this equation, we can immediately get the y coordinate of P. Okay.
Yes. Yes.
So let's get the y coordinate of P. So at x is equals to 5, our y is 5 times 5 plus 2 whole to the power 2 over 3. That is, this is 25 plus 2, that means 27 whole to the power 2 over 3. 27 to the power 1 over 3 is basically 3, right?
Yeah.
27, the cubic root of 27 is 3 and the square of 3 is 9. So the coordinate of P is 5, 9. Okay, now we have to find the equation of the normal because it says the normal of the curve at P intersects the line x plus y is at goes to 11 at point Q. So in order to find the equation of the normal, first we have to get the first derivative of this equation.
Right.
And then substituting the x equals to 5 in our dy over dx expression, we will get the gradient of the tangent that will lead us to the gradient of the normal. Okay. So
Yes,
now,
sir.
so y was given as 5x plus 2 whole to the power 2 over 3. Hence, our dy over dx, that will be 2 over 3 times 5x plus 2. 2 over 3 minus 1 is minus 1 over 3. And if you do the differentiation of 5x plus 2, we will get 5. Okay. So now finally we are getting dy over dx is equals to 10 over 3 times, I can write like this, 5x plus 2 whole to the power 1 over 3. Okay.
Yes, sir.
Okay, now at x is equals to 5, our dy over dx, that would be 10 over 3 times 1 over, we know what, if you substitute 5 here, what it gives? 27, right? 27 1 over 3. 27 whole to the power 1 over 3. So that will give us our dy over dx is equals to 10 over 3 times 1 over 3, which is 10 over 9. So now we will write a line which is not again necessary for this math, but it's a good practice. Always is a good practice to write.
Okay.
So we will write the gradient of the tangent. The gradient of the tangent tangent at P is 10 over 9. So the gradient of the normal, so at P, I didn't write at P, at P it is negative reciprocal. Since they are tangent and normal are perpendicular, so it will be negative reciprocal, minus 9 over 10. Yes. Now you have a coordinate, that is P, which is 5, 9, and you have a gradient of the normal, which is 9 over 10.
Minus 9 over 10. Right?
Yeah, minus 9 over 10. I wrote the minus, but didn't say. Okay. Now we have a straight line equation like this: y minus y1 is equal to m times x minus x1. Didn't we? Don't we?
Yeah, we do.
So we can use this formula to get the equation of the normal. So I can write y minus 9 is equals to minus 9 over 10 times x minus 5. We don't need to simplify this equation at all. Why? Because they didn't ask us to find the equation of the normal in its simplest form.
Right.
What they told us that this equation, that is the equation of this normal, will intersect this line at Q. So let's keep this equation here like this 1, and we have another equation like this x plus y is equals to 11, and now we can write y is equals to 11 minus x. Let's give this equation as 2. Can we substitute this y is equals to 11 minus x here?
We can.
Okay, then so we can get 11 minus x minus 9, that is equals to minus 9 over 10 times x minus 5. Okay.
Yeah.
Now it will give us 2 minus x is equals to minus 9 over 10 times x minus 5. Multiplying 10 to the both side, we get 20 minus 10x is equals to minus 9 times x minus 5. Now in the next line I can write 20 minus 10x is equals to minus 9x plus 45. So now we can write 20 minus 45, that is equals to what?
No, sorry, equals to.
That is equals to 10x minus 9x. So what is 20 minus 45? Minus 25. Minus 25.
Minus 25.
That is equals to x. So that is the x coordinate of Q.
Yes.
That is the x coordinate of Q, right?
Yes, sir.
Now I need to get the y coordinate of Q.
Okay.
So our y will be 11 minus 25. So that would be y will be 11 plus 25, hence 36. So y is equal, so Q is nothing but minus 25 comma 36. So in order to find R, we needed to find the coordinate of P and coordinate of Q, coordinate of P and coordinate of Q, right?
Yes.
So P was 5 comma 9.
Yeah.
We found Q as minus 25 comma 36.
36.
Now, how can we get the coordinates of R? Let's read the line. The point R is a reflection of Q in the tangent to the curve at P. That means the tangent line will be working as a mirror line.
Yeah.
And P should be working as the midpoint between Q and R. So think, you can think like that. If I have a curve like this, here it's P. And if you draw a tangent line, this is a mirror line. So if Q is here, R must be equal distance far from P.
Okay.
That means this distance and this distance are equal. My drawing is not good. Forget about my drawing.
It's okay. It's fine.
Keep up with the concept. Okay.
Right.
So I can now kind of bring a straight line. I need a very small page, so let's bring another page here. So it's like we can think about a straight line where at here it's okay. Let's make it real. So the wait. Here is the middle point. Okay, this is P, this is Q, and this is, why am I making so mess of it? Like here it's here. Okay,
it's okay, you don't have to make it perfect.
No, it's just like I'm just like a bit off to the geometry. Okay, so here we have R. So let R is A comma B, right? Q we found 25 comma 36. P we found 5 comma 9, and R we assumed AB. Understood? So and P is the midpoint of Q and R. So I can write minus 25 plus A divided by 2, that is equals to 5. Can't we?
Yes, we can.
Okay, then minus 20, I can write A minus 25 is equals to 10. So A is 35. Okay, similarly I can write 36 plus B divided by 2 is equals to 9. So b plus 36 is equals to 18. Hence b is equals to 18 minus 36. So b is equals to minus 18. Therefore, finally we found r as 35 comma minus 18. Okay.
Yes, sir. Got it.
So did you understand the whole question?
I did.
Okay. So can we go to the next question?
Yes, you can.
Okay. This is our question number 11, right?
11.
Okay, fine.
Yes.
This is a vector math, a huge picture in front of us. Let's read what they have told us about this given picture. It says that in the diagram, OA is A. That means O from O to A is as A. Okay, so let me give the direction as well. And OB, the entire thing, is O to B, right? Not this O to M. This entire thing, this O to B is B. Okay.
Yes.
The point M is the midpoint of OB. That means this OM is half of B and MB is also half of B.
Half of B.
Since M is the midpoint of OB. Okay.
Yes.
The point N is such that ON is equals to 3NA. Okay, fine. Let's redefine this relationship with the help of the ratio. So I can write ON is to NA is to 3 is to 1, right?
Yes.
So the 3 portion is up to ON and 1 portion is NA. So I can write ON as 3/4 of A. Understood? And NA as 1/4 of A. Clear? Clear?
Yes, sir.
Okay. Now, they have also stated the lines BN and AM intersect at the point X, which is this point. The BX is lambda BN, where lambda is a constant. MX is mu MA, where mu is a constant. Find OX in terms of A, B, and lambda. Okay, fine. So let's draw a line up to OX. Though it's not mandatory. Okay. Sometimes we have to do. I do things, not we have to do. I do things that helps me to visualize the math rather than doing it in an abstract way.
Got it.
So this is OX. First we have to find this OX in terms of the A vector and V vector and the constant lambda. Okay.
Yes, sir.
So how can we write, since lambda is connected with the Bn, so how can we define OX with the help of this Bn and Bx? So I can from O to OX can be written as from how? OX.
OB plus BX.
OB plus
BX.
BX. Very good. So OX can be written as OB plus BX, yes. Right? So OB is directly B.
B.
So OB is B. So OX is equals to B plus. So what is BX? BX is given as lambda BN.
Yeah.
So lambda BN. Yeah. So now we need to find Bn. Okay. So I am doing it here. So Bn is nothing but On minus OB. So On, what is On? On is 3/4 of A. So 3/4 of A minus OB is simply B. So we can bring this value here and we can continue writing OX as B plus lambda times 3/4 A minus B. Now this OX, now actually this math is finished. I mean, like, we have finished our math, but for the rest of the part of this math, I do a certain practice. What practice do I do? I keep all the A together and all the B's together. Here here is only one A, but look, B is here and B is also here. I don't want to keep like this. I want to be as one single variable, vector variable, and keep its constant constant coefficient with it.
Yeah.
So I can write 3 over 4 lambda a, then plus b plus not plus, here is plus b and then minus lambda b. Okay. So now OX is equals to 3 over 4 lambda a, and I can write 1 minus lambda
1 minus lambda
b. So now this is what I usually do. We could have finished the math here, but if this extra part would have been done in the next part.
Got it.
So we just like uh, sort it out so that it can help us in the next part. Okay, so can I go to the next part?
Yes, you can.
Okay, now it says, look what it says, find OX in terms of a, b and mu. So the same thing, now we have to find the OX as well, this OX as well, but in terms of
But in terms of
a, b, and this time mu.
yeah.
But mu was given as like a with the am. What was given? Mx.
MA.
Mx was, look what was given? Mx was, Mx is equals to mu ma.
Mu MA. Yeah.
So first again, so think about by, so now let's thinking about OX. If we write OX, what can we do? We can go OM plus MX, right?
Yes.
So OX can be written as
OM plus MX.
OM plus MX. But OM was half of B. So OX is to half
Yeah.
of B, and here is
Mu MA.
plus mu MA.
Yeah.
So what is MA? Again, MA is OA minus
OM.
OM, right? OA was A and OM was minus half of, OM was half of B, so it would be MA is A minus half of B. Okay.
Yes, sir.
So now substituting here, we can get OX is equals to half of B. This is 2 half of B plus mu times A minus half of B. Again,
Yeah.
B is here, but I don't want to keep this 2B in separate places. I want to write all the B in one place. So OX is equals to mu A plus half of 1 minus mu B. Finished. Right? Now I have two OX. Let's write it here. This OX here, it is given is this. I'm writing just for the sake of writing. OX at first part I got OX as 3/4 of lambda A plus 1 minus lambda B, right? Here this B part we got AX as mu A plus half of 1 minus mu B. Now, since both of them are OX, can we write them equal? Both of them are OX, right? So, can we write them like this? Lambda A plus 1 minus lambda B is equals to mu A plus half of 1 minus mu B. So, now comparing the coefficient of the A vector from the both side of the equation, I can, this is 3/4. Why didn't you say anything? This is 3/4 lambda.
3/4 lambda A.
I forgot to write 3/4. You didn't say anything. So comparing A, I can write comparing
3/4.
Comparing the A vector, I can write 3/4 lambda is equals to mu. Okay, yeah. This is equation 1. Now comparing B, I can write 1 minus lambda is equals to half of 1 minus mu. So we have the mu in terms of lambda. We will substitute this mu. Let's multiply this 2 here. So I get like 2 minus 2 lambda is equals to 1 minus 3/4 lambda. Not mu. Okay. Yeah. So now next line I can write 2 minus 1 is equals to 2 lambda minus 3/4 lambda. Okay. This is 1 is equals to, I can write 2 minus 3/4 lambda. What is 2 minus 3/4? Is basically, I can get, if we multiply this multiply this numerator and denominator 1 by 4, we can get 8 minus 4 minus 3 minus 8 over 4 minus 3 over 4.
Yeah.
Now we have the common denominator and the result is 5 over 4. Why did I do like this? Because you forgot this paper is actually the non-calculator paper. We cannot use the calculator.
Okay, yes.
So finally we got 1 is equals to 5 over 4 lambda. Hence, so our lambda will be 4 over 5. Since we got lambda, we had mu in terms of lambda, didn't we?
Yes, we did.
So now I can write mu is equals to 3 over 4 times 4 over 5. So 4 and 4 gets crossed out. So mu is 3 over 5. So our question number 11 has been finished. Okay.
Yes, sir.
So now I will move to the next question. Okay.
Okay. Yes.
It's an integration math, but started with differentiation. So we call this kind of math as like reverse integration math. Do you remember that I taught in the class?
Yes.
At first, we have to do a differentiation, and with the help of the answer of this differentiation, we have to execute the integration part.
Got it.
Okay, fine. So let's do the differentiation part. What is given? Is given that y is equals to x times e to the power thrice x plus 2. So this is basically fits into the product rule uv, where u is a function of x and v is another function of x. What do we know about the rule of uv? d over dx of u times v is equals to u dv over dx plus v du over dx. You remember that part, right?
Yes.
Don't you?
Yes.
Okay. So now I can write dy over dx as x times d over dx of e to the power thrice x plus 2 plus e to the power thrice x plus 2 times d over dx of x. This line is not necessary. Like you can do the differentiation directly, but I'm just like writing for the sake of writing. Okay.
Okay.
So dy over dx is equal to now the line I'm going to write, that is absolutely necessary. So it will be like x times what is the differentiation of e to the power x? E to the power x is e to the power x, but it's not x. It's something else, right? It's a function of x.
Yeah.
So the chain rule will come in play. So I will write e to the power thrice x plus 2. Now if you differentiate thrice x plus 2, it will give us a 3.
Yeah.
And plus e to the power thrice x plus 2 times 1. So in the final line, I can write like this, a little bit of organized, so nothing else. Thrice x e to the power thrice x plus 2 plus e to the power thrice x plus 2. Okay. So we are done with our differentiation part. So now let's move to the integration part, or we can say the part B. It says, hence find the integration of x e to the power x times e to the power thrice x plus 2 dx. So it's not definite integral. You see, there is no limit given.
Okay. Yeah.
So be very careful about that, because at the last line we have to place an integral constant c. Okay.
Yes.
Okay,
yeah.
Fine. So for this type of math, what do? I start where we have finished the first part, but changing the order of the sides. So I will write here, it is right hand side, but here I'll write this right hand side in our left hand side. I will write like this: thrice x times e to the power thrice x plus 2, and then plus e to the power thrice x plus 2 is equals to dy over dx. Now our first objective should be, how can we bring this left hand side? What this left hand side? This expression. Okay.
Yeah.
All other things will be changed accordingly in order to get this expression. So at first we don't have this term on the left hand side, do we?
No.
So let's rearrange the equation first. So I can write thrice x times e to the power thrice x plus 2 is equals to dy over dx minus e to the power thrice x plus 2. So far so good, right?
Yes.
Okay, now does it have 3 in front of it? It has x times e to the power thrice x plus 2 dx. So far
But it
we
does not
got
have three.
yeah, it doesn't have 3 as a coefficient. So let's divide the entire equation by 3. Now I will have x times e to the power thrice x plus 2 is equals to 1/3 of dy over dx minus 1/3 of e to the power thrice x plus 2. We are almost there, but one thing is still missing. What? Here another dx is multiplied, but here we don't have any dx, do we?
No, no.
So what can I do? I can multiply a dx here, I can multiply a dx here, and I can multiply a dx here.
Okay.
Now this dx and this dx gets cancelled out. Since it gets cancelled out, now in the next line I can write this summation sign, okay, and then x times e to the power thrice x plus 2 dx is equals to 1 over 3 is just a coefficient, so let's keep it outside. It will be dy minus again 1 over 3 e to the power thrice x plus 2 dx. Okay.
Yes.
Now we are almost
There.
there. Yes. Okay. So now it says the integration of dy is simply y. So the result is 1/3 of y minus 1/3 of e to the power thrice x plus 2, because integration of e to the power x dx is also e to the power x plus c. But here again, this is not only x, this is x plus, it's a function of x. So what we have to do, we have to divide the differentiation of e to the power, not e to the power, this function. So thrice x plus 2. Okay, what do we have? What will we have? The 3 here, 3 from the denominator. Did you get it?
Yes.
And here we wrote y, but what was y given? Y was x times e to the power thrice x plus 2.
Yes.
So on the final line, I can write, not in the final, maybe second final line, x e to the power thrice x plus 2 dx is equals to 1/3 of x times e to the power thrice x plus 2 minus 1/3. Here again we will have 3 times e to the power thrice x plus 2. Do you know what have I missed intentionally? I was checking that. Can you get this part? I missed something that I told earlier. This is not integration, definite integral. This is an indefinite integral. So we have to place an integral constant.
Right.
And you did not say anything. I was testing you.
I'm sorry.
X. So answer is, so now this must be our final line. Thrice x plus 2, 1/3 of x times e to the power thrice x plus 2. So 1 over the both of the 3 are in the denominator, so I can write minus 1 over 9 e to the power thrice x plus 2 and plus c. So our paper is finished. Okay.
Yes.
Okay. Bye.